Forget everything you think you know about little green men and flying saucers. This is not about blurry photos or campfire stories. This is about hard, cold, undeniable science. We are standing at the precipice of the greatest discovery in human history, and you haven't heard the half of it yet. Today, we are not asking if we are alone. We are asking, where is the proof? And the answer might be closer and stranger than you ever imagined. We are living through a revolution right now, in this very moment. For thousands of years, humanity looked up at the stars and wondered, what is out there? We told stories, we built myths, we created gods in the sky. But in the last 30 years, the question has shifted. It's no longer a philosophical question, it's a scientific one. And the scientists, they are getting nervous because the evidence is starting to pile up in a way that is impossible to ignore. Let's start right in our own cosmic backyard, Mars, the red planet. For decades, we sent orbiters and landers to a world that looked like a barren, frozen desert, dead, silent. But then, we started looking closer. We sent rovers, these little robotic geologists, to drive across its surface, and what they found, it changed everything. They found sedimentary rocks, rocks that are formed by layers of silt and sand settling at the bottom of lakes, ancient, massive, flowing lakes. They found river deltas, exactly like the delta of the Mississippi River, formed where flowing water dumps its sediment into a larger body. They found minerals like clays and sulfates, which, on Earth, only form in the presence of water. This isn't speculation anymore. Mars was not just a damp world. Mars was a blue planet. It had an ocean that covered nearly half of its northern hemisphere. For billions of years, while life was just starting to cook in the primordial soup on Earth, Mars had a giant salty ocean lapping against its shores. Now think about that. If you take a scoop of seawater from any ocean on Earth, you will find life. It's teeming with it. So the question isn't, was Mars habitable? The question is, did life take that same opportunity there? We don't know yet, but the evidence is so compelling that NASA and the European Space Agency have launched a multi-billion-dollar mission to bring those rocks back home. We are going to pick up a piece of Mars and put it under a microscope in a lab on Earth. That is how close we are. But the search doesn't stop at our rusty neighbor. Let's zoom out, way, way out. Look up at the night sky. Every single point of light you see is a sun. And for a long time, we assumed our solar system was normal. We assumed our family of planets was how the universe worked. We were wrong. In the 1990s, we started finding planets orbiting other stars. We call them exoplanets, and the universe, it turns out, is absolutely stuffed with them. The Kepler Space Telescope and now the TESS mission have given us a number that should make your jaw drop. Scientists now estimate there are more planets in the universe than there are stars. Let that sink in. That's not just a big number. It's a number so vast it breaks the human brain. It means for every grain of sand on every beach on Earth, there are 1,000 planets out there. And not just any planets. We are finding small, rocky planets just like Earth, orbiting their stars at just the right distance where water can exist as a liquid. We call this the Goldilocks zone. Not too hot, not too cold, just right. We've found thousands of candidates. We've confirmed hundreds. The nearest one, Proxima Centauri b, is practically next door, cosmically speaking. So, the stage is set, the ingredients are everywhere, the real estate is available. The only question left
is the most profound one. Did life ever sign the lease?
And this is where the science gets weird. Because to answer that, we have to look at life itself. What is it? How do you define it? And if we find it, will we even recognize it? We assume alien life will look like us. 2 eyes, a nose, a mouth. But that's just our ego talking. Evolution on Earth took a billion-year detour through slime molds and jellyfish before it got to us. On another planet, with a different chemistry and a different history, life could be anything. Imagine life on a methane lake on Saturn's moon, Titan. It wouldn't be based on water. Its cells could be made of different compounds. We wouldn't be looking for little fish. We'd be looking for something so alien we might walk right past it and call it a rock. Or consider the shadow biosphere theory right here on Earth. Some scientists speculate that a whole different tree of life, a sort of weird life, could be living among us, but based on a different set of chemical rules, and we haven't even noticed because we don't know how to test for it. This brings us to the most tantalizing piece of evidence we have. It's not a little green man, it's a rock, a very specific rock that fell from the sky in Antarctica in 1984. It's called ALH 84001, and it came from Mars. We know this because gases trapped inside it perfectly match the atmosphere of Mars measured by the Viking landers. This rock was blasted off the surface of Mars by an asteroid impact millions of years ago, floated through space, and crash-landed on Earth. And when scientists looked inside it with an electron microscope, they saw something that caused a worldwide sensation. They saw structures, tiny tubular worm-like structures fossilized in the rock, structures that on Earth are the unmistakable calling card of ancient bacteria. They also found chains of magnetite crystals, which some bacteria on Earth use like a tiny compass to navigate, and polycyclic aromatic hydrocarbons, which are organic molecules that are often the breakdown products of life. For a moment in 1996, the world held its breath. The President of the United States stood at a podium and announced that we might have found evidence of life on Mars. It was an electric moment. And while the scientific community is still divided, some say it could be formed by non-biological processes. The point is this: the debate is real. It's not fringe science. It's happening in the hallowed halls of NASA and universities around the world. The evidence is sitting there under glass, and we are arguing about whether it's a fossil or a fluke. And then there are the moons. Jupiter and Saturn aren't just gas giants. There are many solar systems with dozens of moons, and 2 of them are, in my opinion, the most promising places to find life in the entire solar system. Europa, a moon of Jupiter, is covered in a smooth, icy crust, but underneath that ice is a global ocean, an ocean with more liquid water than all of Earth's oceans combined. And we know it's there. We can see the cracks in the ice from tidal forces, and we've even seen plumes of water vapor shooting out into space, just like Old Faithful. Down there, in the dark, there could be hydrothermal vents, just like we have on our ocean floors. And on Earth, those vents are oases of life, teeming with creatures that never see the sun. And then there's Enceladus, a tiny moon of Saturn. It shouldn't be geologically active. It's too small. But the Cassini spacecraft flew by it and discovered something astonishing. Geysers, giant jets of water ice and organic compounds blasting out from its south pole, feeding one of Saturn's rings. Cassini flew through those plumes, it tasted them, and it found complex organic molecules, the building blocks of life. And it found evidence of hydrothermal activity on the sea floor below its icy shell. We have a world right now with liquid water, a source of energy, and organic chemistry. That is the trifecta. That is the recipe for life. So we have a solar system that is practically screaming at us. We were alive. We could be alive. And we have a universe of 1 trillion planets waiting to be explored. So why the silence?
Why, if the universe is so full of potential, haven't we heard a peep? This is the Fermi paradox, named for the physicist Enrico Fermi, who famously asked, "But where is everybody?" If life is common, the universe should be buzzing with signals, with alien civilizations, with galactic empires, with radio chatter. We've been listening for decades with massive radio telescopes, scanning the stars for a deliberate signal, an intelligent whisper in the cosmic static. We've heard nothing, just the hiss of the Big Bang and the crackle of dying stars. This silence is, in itself, a piece of evidence. It's a clue. Maybe the great filter is ahead of us. Maybe all civilizations get to a certain point of technological advancement and then destroy themselves with climate change, nuclear war, or a pandemic they can't control. That's a sobering thought. Maybe space is so vast and the laws of physics so limiting that no one can ever travel far enough to meet anyone else. We are separated by oceans of time and space so immense we might as well be in separate universes. Or maybe we're just not listening the right way. We are searching for radio waves because that's what we use. But what if advanced life evolves beyond radio? What if they communicate using something we can't even comprehend, like modulating neutrinos or gravitational waves? We are like a tribe in the Amazon, listening for drums, while the world around us is buzzing with cell phone signals we can't detect. And this brings us to the most exciting and controversial search of all, the search for technosignatures. Not just microbes, but technology. We are now building telescopes so powerful, like the James Webb Telescope, that we can do something incredible. We can take a picture of a distant exoplanet. We can split its light into a spectrum, and we can look for the telltale signs of industry. We can look for chlorofluorocarbons, the pollutants that destroy ozone. If we see that in an atmosphere, it means someone is polluting their air, just like we did. We can look for the glow of massive cities on the night side of a planet. We can look for giant engineering projects like a Dyson sphere, a hypothetical megastructure built around a star to capture all of its energy. Imagine that. Imagine the James Webb Telescope, or its successor, finding a star that is winking out in a strange, unnatural pattern, not because of a planet passing in front of it, but because something huge is orbiting it, something built. That discovery would not just be a headline, it would be a rewriting of the human soul. It would tell us that we are not special, that we are not alone, that our hopes, our dreams, our art, and our struggles are a cosmic commonplace. The search for alien life is not just a scientific endeavor. It is a mirror. It forces us to look at ourselves. Are we a violent, self-destructive species destined to wipe ourselves out before we can reach the stars? Or are we the universe's way of waking up, of becoming conscious of itself? Finding another life form, even a single microbe on a Martian rock, would answer that question. It would tell us that the spark of life is not a miracle. It's a law of physics. It's what matter does when you give it enough time and the right conditions. For now, we wait. We watch the data stream down from Jupiter, from the Europa Clipper mission set to launch soon. We watch the Perseverance rover as it carefully seals its tubes of Martian rock and soil, leaving them on the surface for a future mission to pick up. We hold our breath every time a new exoplanet atmosphere is analyzed. The evidence is mounting, the case is building, and one day, maybe in your lifetime, the phone will ring. It won't be a phone, of course. It will be a supercomputer at a radio observatory, triggering an alert. A scientist will look at a screen and see a pattern that cannot be explained by nature. A pattern that is mathematical. A pattern that is intelligent. And in that moment, the story of humanity will split in two. Everything before that moment and everything after. So keep looking up, keep wondering, because the universe is not silent. It's just waiting for us to be smart enough and brave enough to finally hear the whisper. The evidence is out there right now, waiting to be found. The search has only just begun.